All right, let's try problem 5.60. A person with compromised pinch strength in his fingers can only exert a normal force of 6.0 newtons to either side of a pinch-held object, such as a book shown in the figure. What is the heaviest book he can hold onto vertically before it slips out of his fingers? The coefficient of static friction of the surface between his fingers and the book cover is 0.80. Okay. So to find the frictional force, call it F sub k, is this going to be equal to the static frictional force, mu sub s, times the normal force. And we're told that he can exert a normal force of 6 newtons to either side of the book. So we know that he has to have one force coming off this way, and there's going to be a normal force coming off this way, right, from his two fingers. So this is going to be 6 newtons. This is going to be 6 newtons. So that means just for one side of the book, right, he's going to pinch it, and it's just going to be mu s, which is 0.80, times 6 newtons. And so this is going to be equal to 4.8 newtons. So the frictional force for one side of the book, if it's dropping, it's going to be dropping downwards, right? So the frictional force is going to point in the opposite direction of the motion, and it's going to be equal to 4.8 newtons. But this is going to happen on both sides of the book, right? So there's going to be another 4.8 newtons on the other side of the book. And so 4.8 newtons plus 4.8 newtons is going to be the total frictional force on the book, which comes out to 9.6 newtons. And so what this means is that if this book weighs more, has a weight greater than 9.6 newtons, this book is going to fall. It's going to start slipping. And so that means if this book, so the maximum weight this book can have is 9.6 newtons. So if we want to get that into kilograms, how do we do it? Well, we know that force is equal to mass times the acceleration, right? And if we're trying to find the mass, all we have to do is divide by the acceleration. So the mass is equal to the force over the acceleration. And in this case, the acceleration is going to be due to gravity. So we have the mass is going to be equal to the force, which is the weight of the book, which is 9.6 newtons, over 9.8 meters per second squared, right? The acceleration due to gravity. And so this comes out to 0.98 kilograms. So that's the most that this book can weigh, and that we could hold on to it. And so that's problem 5.60.